Good morning everyone, and this is the very last video before the summer holidays. We don't know what September's going to look like exactly at the moment, but I'm very much hoping that I'll be able to see you face to face rather than talk at you via YouTube. But I assure you that we are up to date, and if you followed the videos and kept up and done the practice, then you are not behind in terms of maths at all. So well done to those of you who have done that, because I know at times it has been tricky to motivate yourselves, and I congratulate you for keeping going. So we are today talking about where's the right angle triangle, but with missing sides. So last lesson was where's the right angle triangle with missing angles. This is where's the right angle triangle with missing sides. I'm going to go through one problem with you together, and then you've got three to try on a separate sheet which I've attached, and I've also attached worked solutions to those, so you hopefully will be able to head off into the summer holidays with a nice clear understanding of what we're doing here. We've got a situation where we've got a tent peg. I don't know if any of you are planning camping now that the restrictions have been relaxed a bit. Propping up a tent, and the only thing we know is that this angle here between the guy rope and the ground is 60 degrees, and we've got three different scenarios to work with, and so hopefully where's the right angle triangle, that's fairly straightforward, but I'm going to do A, B and C separately. So question A, firstly, I'm going to draw out actually let me do that so you can see the diagram. I'm going to do a quick sketch of the right angle triangle in this problem. Here we go. And that's 60, and that's my right angle. And in part A, I'm told the peg is 1 metre from the bottom of the pole. So that's 1, and I've got to find the height of the pole. So there we go, that's my problem. So let's label up our sides. H followed by A followed by O, hypotenuse. Adjacent is the other side that makes up the angle. Opposite is the side opposite. Now what sides are involved in this? Well, I know the adjacent and I'm trying to find the opposite. So quick sketch of Misaka Toa. Which of those involves opposite and adjacent? It's tan Toa. So let's write the rule. Tan of 60 is equal to O divided by A, and I know that O is the side I'm trying to find, X, and A is 1, so tan 60 is equal to X divided by 1, and well, that means X is equal to tan 60, doesn't it? We multiply by 1, but it doesn't make any difference at all. And so I'll do 1 times tan 60. This is not shift tan, we know the angle, so we do 1 times normal tan 60, and it gives me a square root on my calculator as an answer, so I'm going to S to D it and round it to 1 decimal place. Doesn't tell me in the question, no, it doesn't tell me, so I'm going to go with 1 decimal place. That seems to make sense. Sorry, you can't see that. There we are. Right, so that is part A. So what I want you to have a go at is part B. So start from scratch again with your right angle triangle. Angle still 60, but this time we're told the length of the rope is 1.4 meters, and we've got to find the height of the pole. Have a go, see if you can do that one. I'm going to pause the video, show you the answer in just a minute. Okay, so I am trying to find the opposite side, and I know the hypotenuse this time around. So O and H is sine. So I plugged in the numbers, missing value on the top. Remember, there are two sorts of problem with missing values. You've got the ones where the missing value is on the top, which are nice and easy. You've got ones where the missing value is on the bottom, and in those situations you have to do the switcheroo. But this was a nice easy one. I get 1.2 to 1 decimal place. I think it's always good to do a quick check that it makes sense. I mean, if that's 1.4, And yeah, it makes sense that that's 1.2. It clearly can't be longer than 1.4, can it? So it seems that that's pretty reasonable. Okay, before I leave you, see if you can do part C in a similar way. Again, start from scratch with the 60-degree angle, and then have a look at what they tell you and what you are being asked to work out. I'll pause, show you the answer in just a moment. Okay, so I know that that length is 2 in this question, and the length of the guy rope. I'm asked to find the distance of the peg from the base of the pole, so that's that distance. So that's H and that's A. H and A is cos. Again, missing value on the top, so this is a nice easy one. And cos 60 is an unusual one because it gives you a nice round value. Cos of 60 is 0.5, it's a half. So you actually get 2 times a half, which is 1. Most of the time, the sine, cos and tan of angles gives you a horrible value, but there are a few that give you nice round numbers. So, we've done 3 examples together. You've got another 3 questions attached, and I'd like you to have a go at those in a similar way. And then I've attached worked solutions, and hopefully you can check those yourself. So no need to submit, but if you are stuck and you can't see how I got my answer, then by all means get in touch. And I hope the next time we're talking, we'll be face to face, sat in the classroom.